Welcome to the ET335 Quartus Starter Graphics Entry Lab in Vmware. This one is without the Altera board. Here we are at my home computer. We're going to go ahead and open up Vmware, the driver for it, which I showed in a different video. We're going to go to VDI Los Rios, open that up, and enter your password. Okay, let's go to electronics. And they're loading the desktop. Okay, once we're on the desktop, let's double click our Quartus. And it should fire right up. And if it asks about a license, just go and say run it. And let's just go ahead and create a new project in our project wizard. Next, let's go ahead and save it to our drive here, and let's call this guy graphics. And you could call it anything you want, but everything needs to match. And let's go ahead and just go ahead and finish this because we don't have a file to do. And we're going to, let's just choose the Cyclone 2, pin count 484, and let's just go use this one right here, the EP2C20F484C8. That'll work. And just go to finish. And let's open this up a little bit. I'm just going to drag it out there. And that's good. Okay, let's go to File, New, and we're going to do a block diagram schematic file. Okay, and now we're going to build our OR gate. So let's go to the gates, and we're going to drop down our menu, and we're going to go to primitives, logic, and this guy is going to be a OR2. And let's see if I could control scroll, make them bigger, and I can. Okay, so now we're going to go back to our here, and we're going to go back up. We're going to close out logic, and we're going to do pins. And we're going to do input. Well, I am going to do this. So we got two input pins. Escape. And move it over so it fits on my drawing. And I'm going to click on them, make sure they connect. Unclick, and then we can move them out of the way to... And since we're here, we're going to go ahead and change pin number, pin A. And we're going to go pin number 2 and make them B. And we're going to go back to our graphics. And we're going to do output. Okay. Let's go ahead and make him LED. I think that's what the lab says. Well, let's see, I got this pop-up window. Let's go ahead and change it in there. That'll work for me. There we go. And we have our schematic. Okay, so let's take a look here and let's do a compile. So we could go here, or we could go to processing. Let's see what we could do in processing. And start compilation, or we can do the arrow here. Do I want to save changes? Yes. I'm going to, yep, I got it. We're going to call it graphics, and we're going to let it compile. And warnings usually don't matter, but errors will collapse this. Green is good. We'll go ahead and let it finish out. Okay, we got a full compilation. Don't worry about the warnings. That just makes it go faster, more small. We're perfect. So let's go ahead and close out of our summary. Here we go, compilation report. Close it out. And let's go to the pin wizard. And this guy's right here. Where's he at here? Right here. Assignment editor, pin planner. There's a couple ways we could do this. We could go ahead and just put it in the location. But let's go ahead and open up this guy. A little larger, and we're going to use the graphics. So we have R22, so we want R20 is going to be our output. So let's go to LED, and we're going to select R20. So we're going to R, and we're going to go to the little diamond here. And let's open it this guy so we can see the rest of it. There we go. And the node name's going to be LED. And we're going to go reserve. We're going to go output drive in VCC because we want it to drive an LED. Good. And then we're going to go to A. We'll just go back to this guy, and we're going to go to 19. R19. Node name is B. Excuse me, A. He's going to be input tri-stated. And good. And then we're going to go to B. And we're going to go to R19. And we're going to make him B. We're going to make him as input tri-stated. And we could close out of this. Once we have all of our pins matched to our IC, let's go ahead and compile it again. Perfect. Okay, once we have everything off the screen, we're going to go to File, New, and we're going to go all the way down to University Program VWF. Okay. And we're going to go to Edit, and we're going to Insert, Node or Bus. And let's see, we're going to Node Finder. We're going to go to the triple arrows here, and this will populate everything, or it should. Okay, there we go. Go to List, and we're going to go to the double arrow here so that we populate everything. We're going to go OK. Okay, and here we're going to select A, and we're going to pick clock. We'll go ahead and use 10. We'll go to B, and we're going to go to clock, and we're going to make it 20 so that we get a good binary count here. Okay, and let's go ahead and simulate. So we're going to go to simulation. We're going to let's do a functional. See what happens here. And over here, which I can't show, is our simulation window. I'll bring it over. If it's green, that means good. So here it is. All green means good. And we should get an output for our LED. Okay, I cut off their thinking so we could take a look at this. So if I do a control, let's see if I can do a control scroll. Nope. And let's see, view, zoom in. So we have a control space. So let's do a control space. Okay, let's take a look at this output. Some way or another, I keep erasing the window here. I'll see if I can find it. But anyway, what we're showing here is A. We have 0, 1, 0, 1. On B, we have a larger 0, 1. So we have every possible 0, 1, 2, and 3. And when we look at it, this is an OR gate, so anytime it's a high, either one of these is a high, we're going to get a high out. So this is correct for an OR gate.